Hey guys, welcome to Unit 3, Lesson 5B, which is factoring part 2. So what we're looking at with these is we're going to look at greatest common factors, and then we're also going to look at special patterns when we're factoring. So the first one, example 1, says before, and then we have the factoring. So this is, if I were to multiply the 5x with the 3x, I would get 15x squared. And then if I were to multiply 5x times negative 7, I would get minus 35x, which is exactly what we have down here. So the reason is because 15x squared minus 35x, the greatest common factor that we could pull outside of them is 5x. 5 is the largest number that goes into both of them, and then x is the largest variable that goes into both. So then we would just be back to where we started, which would be that 3x minus 7. And then this one right here, if we were to FOIL everything all out, we would end up with this right here. And from our practice yesterday, we know that x and x, factors of 30 that have a difference of 1. So the sign for x is positive, so it's got to be bigger. The bigger number is positive, which would be 6, and then minus 5, which is what we had up above. Okay. So then we have some special factoring patterns, and these are called difference of perfect squares. We've seen these before. So whenever you have two squares subtracting from each other, and then the first one has an x squared next to it, or the second one, it also works that way too. So we have to think about, well, what is the square root of 121? And it's 11. So we get 121x squared from 11x times 11x. And then we get 16. That's a perfect square as well. That is 4 times 4. But the difference of square part comes in where we have one sign's positive, one sign's negative. We had this when we were talking about complex conjugates. So the pattern is a squared minus b squared equals a plus b times a minus b. So if you can figure out what the square root of those terms are, you can figure out what a and b need to be, and then just plug it in. So this one here, we still do the double parenthesis. X squared comes from x times x. 25 comes from 5 times 5. And then we have 1 plus, 1 minus. This one we have 4x squared minus 9. 4x squared comes from 2x times 2x. 9 comes from 3 and 3. Plus, minus. And it doesn't matter which order we put the plus or minus to, by the way. This one, x squared is a perfect square, x and x, 9 is a perfect square, 3 and 3, plus, minus. Then we also have another special factoring pattern. It's called the perfect square trinomial. So this is if we have a squared minus, well, I'll do them separately here. So this one is a squared minus 2ab plus b squared. And this one is a squared plus 2ab plus b squared. And then what these equal is a minus b times a minus b, or we also know that as a minus b squared. And then this one over here is a plus b times a plus b, which is a plus b squared. Now this pattern we've seen when we were completing the square, where we would just take the two binomials that were the same, rewrite them as the square. Okay. So if we were to factor this one, 4z squared minus 12z plus 9, I'm just going to write my work down here. So 4z squared comes from 2z, and then 9, perfect square, that comes from 3 and 3. And then the middle term is minus because signs are the same, both negative. So then we just rewrite it as 2z minus 3 squared. You don't need to memorize this pattern up here. You can still factor it without necessarily doing that part, but this is you just have to recognize the fact that it's a perfect square trinomial, so it starts and ends with a perfect square. And then the middle term is 2 times the terms added together. Okay, then we got the next one, which I'm going to do down here. This one we recognize the perfect squares of 36w squared comes from 6w. 25 comes from 5. And then signs are the same, both positive, so we put plus plus, which becomes 6w plus 5 squared. Now, factor by finding the GCF, which stands for greatest common factor. This is what we should always be looking for whenever we're factoring. That's usually the number one mistake when I see factoring is people forget to take out the greatest common factor first. So the greatest common factor is a term that would divide into everything, and we pull it outside like it's parentheses. So this first one, we look at the numbers first. So we have 4, -2, -6. Those are all even numbers, so we can actually pull out a 2 from everything. Okay. Then we look at the variables. I have x cubed, x squared, and x. So the largest variable term I can pull out is just a single x. Then when I pull them out, I'm actually dividing them out. So 4x cubed, if I divide 2x by that, I end up with 2x squared. I have 1 less x, and then I took 4 divided by 2, which left me with 2. Next part, -2x squared divided by 2x would give me a minus x, because now I'm short 1 x and the 2's gone. And then the last part, I get rid of all the x's and I'm left with -3, because -6 divided by 2 is -3. Now what I need to do is I actually need to try to factor what's in the parentheses. So 2x stays the same, but let's see if we can factor these two here. So factors of 3, you'd probably want to use the box method for this one, but I'm a little short on room. So we know that it would have to be 2x and x. So this is going to end up being 1 and 3 are the only way that we can split up the other one. And if we did 3 on the other side, then we'd have 2 times 3, which would give us 6. That'd be way too big. So we actually need it to be -3, +1 like this. This is how we would factor that. If you need a review on how to factor something like this where the a value isn't 1, go check out the video in part 1 again. This one, we would be able to take out 3, because 6 and 3 are both divisible by 3. And then y to the 4th and y squared. The biggest variable term we can take out is a y squared. So now when we divide those out, we're left with 2y squared plus 3y squared divided by 3y squared is 1. Make sure that you write the 1 in there. And now we can't break that up any further, so this is our answer right here. This next one, we can take out a 3 from both of the terms. So we're left with x squared minus 4. Ooh, that's a special pattern, so we can actually factor that. That's a difference of squares, so that's going to be an x plus 2 and an x minus 2. Another one that is easy to forget. This next one here, 6x cubed minus 15x squared minus 9x. So look at the numbers, 6, 15, and 9. We can take a 3 out of all of those. And then x cubed, x squared, x, we can take a single x out. Now when we divide the first one, we get 2x squared minus 15x squared. That would give us minus 5x. And then when you divide -9x by 3x, you get minus 3. Okay. I'm going to do the box method for this next one here. So just as a refresher. So the box is a times c on the top, and then the middle part is b. So a times c is going to give us 2 times -3, which is -6. And then the b value is -5. So factors of -6 that combine to make -5 are going to be -6 and +1. So then I got to do my box after I do my little cross section. Remember, the first box is reserved for the first term, which is 2x squared. The last one is -3, and then these two boxes are filled in by these. So it's negative 6, and we throw an x next to it, and then 1x, or just x. Then we have to find all of the greatest common factors that go with these. So 2x squared and negative 6x, those both have a 2 that we can factor out as well as an x. And then 1x and negative 3 don't have anything in common, so we can just take out a single 1. 2x squared and 1x, we can take an x out of those. And then negative 6 and x and negative 3, we can take out a negative 3. So for this one, we end up getting 3x stays on the outside. Now I have my factors right here and right here. So it's going to be x minus 3, and then it's going to be 2x. This would be plus 1 because it's a positive 1. So there's our factored of that. Next, we have 7m squared plus 9m. 7 and 9 don't have any common factors other than 1. And then m squared and m, we can take out a single m from both of those. So we're left with 7m plus 9. And you can't factor 7m plus 9 any further, so we would just circle our answer right there. Okay, on to the last one here. So 3x squared minus 27x plus 24. We can only factor out a number, which would be 3. 3 goes into all of those. Can't take out any variables because the last term doesn't have an x. So then we get x squared. Negative 27 divided by 3 is negative 9. We still have the x next to it. And then 24 divided by 3 is 8. So let's see if we can factor this out. So x squared comes from x times x. Factors of 8, signs are the same, both negative, so it's minus minus. Factors of 8 that combine to make negative 9. Well, that would have to be negative 8 and negative 1. So there's our answer right there. All right, so trickiest part about this is, again, make sure you look for the greatest common factor first. Can you pull anything out? Then you want to look for special patterns like what we had right here. That's that perfect square. And if your a value isn't equal to 1, like what we had with this one after we factored the 3x out, we had this 2 down here. You got to use that box method is the quickest way. You can do it in your head, but I would recommend the box method.